So let's apply these relationships. Let's start off with a special angle. So for example, I know that the sine, well, let's actually figure this out. Let's pick the sine of 2 pi over 3. And I picked 2 pi over 3 for a reason, because that's kind of what I tried to draw up here. So remember, 0 radians puts me over here, right? Pi over 2 puts me up here. Pi over 3 would put me right here, right? It goes pi over 6, pi over 4, pi over 3. So I was attempting to draw 1 pi over 3, 2 pi over 3s to get me to here. So that's what I was trying to draw here. So I was wishing in my picture that that angle was really 2 pi over 3 to the best of my artistic ability. And it looks pretty good, right? So this would be 1 pi over 3 to there. Sweeping over again would be 2 pi over 3. And if I kept going by pi over 3, that should put me here at 3 pi over 3, which is pi, which is 180 degrees, which that looks like the right spot. All right, what are the values of this? Well, at this point right here, y is bigger than x. So the x value here should be 1/2, and the y value should be the square root of 3 over 2. Thinking about my knowledge of the first quadrant in those numbers, and I just made a mistake. That should be -1/2, shouldn't it? Now, what is the sign? Is the sign the y value, or is the sign the x value? The sign is the y value, so the sign of 2 pi over 3 ought to be square root of 3 over 2. All right, let's keep going. On this circle, since I haven't mentioned a radius, but I've been using the idea that the sine is the y value and the cosine is the x value, I'm assuming at the moment my radius to be 1. And this number right here is the y value. So what do I know at the moment? I know that y is the square root of 3 over 2. I also can say that x is 1/2 in this situation, and I can say that the radius is 1. So now that I know x, r, and y, I can tell you what all of those things are right there. All right, so I know that the cosine of 2 pi over 3 has to be, oops, -1/2, right? Don't forget the negative. Quadrant 2 here, quadrant awareness. Tangent, what's the tangent of 2 pi over 3? Well, remember the tangent is equal to the y value divided by the x value. So that would be y is square root of 3 over 2, x is -1/2. The halves divide out, positive over a negative is a negative, so that should be negative square root of 3. How would I check that? I can just plug this into a calculator, plug that into a calculator, see if they match. Let's keep going. Secant, what would the secant of 2 pi over 3 be? Okay, secant is the radius divided by the x value. Radius is 1, x value is -1/2. 1 over would be -2. So on a calculator, if I ask, hey, what's the secant of 2 pi over 3, it would say -1/2. If your calculator has a secant button, a lot of calculators don't. How else would we figure out the secant of 2 pi over 3? Well, we just did it by knowing x, y, and r. So that would be one way. Alternative way is to remind myself that the secant is also 1 over the cosine of theta. So on my calculator, I can plug in, hey, calculator, what is 1 over the cosine of 2 pi over 3? That's a 3. It should say it's -2. So there are ways to use our calculator, even if they don't have secant buttons. Some do, some don't. All right, where are we? Secant, cotangent. Cotangent of 2 pi over 3. That would be x over y. So x is -1/2. Y is the square root of 3 over 2. Negative over a positive is negative. 1/2 divided by 1/2 goes away, and the square root of 3 is stuck in the bottom. So that should be the answer. Now we could rationalize the denominator, but I mentioned previously I'm not a big fan of that, so I like that answer better. So don't rationalize the denominator unless the problem says, please rationalize the denominator. It's not necessary mostly. And what do we got? Cosecant of theta. Oh, theta is 2 pi over 3 precisely. cosecant is the radius, 1 divided by the y value, square root of 3 over 2. 1 over a number means flip it, 2 over the square root of 3 would be what that is. And if my calculator, if I want to check that that's true, my calculator might not have a cosecant button, then I can just remember, oh, the cosecant is 1 over the sine of theta. So I could just ask my calculator, is 2 over the square root of 3 really the same as 1 over the sine of 2 pi over 3? So I'm going to leave it to you to check that on your calculator if you wish. So I urge you, draw pictures for these problems. It'll help you solve them. You have to know these relationships too.